All right, hello once again. Jeff Scott of Rankin Technical College. We've been talking databases, and we're in Chapter 3 of our SQL Beginner's Guide 3rd edition textbook. In Chapter 3, we're going to jump back and look some more at some of the data and the schema, the data, etc. that we put in for this music database. So this chapter, which starts on page 49, is entitled Creating and Altering Tables. Our objectives: we want to be able to create an SQL table, specify column and data attributes, create user-defined types, specify column default values, alter SQL tables, and delete SQL tables. SQL supports 4 types of database tables. The first are what are referred to as persistent tables. Those are the ones that you create using a create table statement. Those are the sole ones that we'll concentrate on in these series of lectures. There are also global temporary tables, created local temporary tables, and declared local temporary tables. I'm not going to talk about any of those. Here is the syntax on the bottom part of page 51 for creating tables. Okay? And again, the one we're going to be concerned with is just the regular create table one. Now let's go back and let's look at let's take a look at one of these tables that we've already created. And I'll use one that's fairly big here. So we'll use this one. Again, you'll notice that what I have here is what I've got listed in gray because I've highlighted it. Everything that's in there that's blue, I made uppercase. Not mandatory. But I made it uppercase so that it would stand out. All right? And those are keywords. So create is a keyword, table is a keyword, int is a keyword, primary and key are keywords, varchar is a keyword, not is a keyword, null is a keyword, int is a keyword, constraint is a keyword, foreign and key are keywords, references is a keyword, check is a keyword, and is a keyword. Now, I may have mentioned this to you before, and I don't want to get sidetracked, but I do want to mention one thing, and that is, if I come in here and I type in MySQL reference manual PDF, for example, and I'll just grab this one right here. I know we looked at this in an earlier chapter, but I believe this was the document with 5,280 pages in it, and it's a PDF. Of course, don't come in by me to print this out. But the point is, virtually everything that you'd want to know that's specific to MySQL in this case, you could find by using this reference manual. Oracle has a similar one. Microsoft's SQL Server has a similar one, etc. But when we look here, the syntax is the word create, followed by the word table. So these are both, this is data definition language, not data manipulation language, data definition language. Because what we're doing right there is we are creating the schema for a table. That table will be called compact disks. That table will have 4 fields in it. It will have a primary key field that's called compact disk ID. That field will be an integer, which means it's a whole number, and it will also be auto increment, which, as you see in there, is not a keyword. What that means is the first one we put in, give it a number of 1, the second one a number of 2, the third one a number of 3, etc. And again, it's a primary key, so it's a unique record identifier, so each compact disk ID must be unique. Next, we have a field that's called CD label. It's a varchar 60 not null. Well, breaking that down, varchar means it's a variable, that's the var part, variable character length field. The character is the char. It can be up to 60 characters. Since it's not null, it must have at least 1 character in it. So it can have anywhere between 1 and 60 characters in it. Then we've got, and it can't be null, label ID and in stock. They're both integer values. We're assuming that you can't have a number in stock that's part of like a part of something, so that's why it's an integer. They're both not null, which means they both must contain a value. Then we have these two special constraints here. The first constraint that you see starts with FK. FK is short for primary key, and it's a way to relate two tables together. We're going to get to this in a later chapter. All right, but it's relating together the label ID field from the compact disks table to the label ID field of the CD labels table. Finally, we've got a check constraint in there, and that starts with CK. You can name this whatever you want. Literally, I could name this Fred, and I could name that Barney, and it would work. But you typically take foreign key constraints and start them with F key and give it some kind of an idea of what it's about. You typically take check constraints and start it with CK and give it a descriptive enough heading that people can look at it and know what it's about. So for the in-stock check, you want to check to make sure that the stock is greater than 0 and it's less than 50. So valid values for in-stock are 1, because that's greater than 0, through 49, because that's less than 50. So you should be able now to take a look at any of these tables that are in here, any of the 8 tables, and explain what they're about. Okay? And that's kind of what they're getting into here in this create table and talking about the stuff that's in here. Right? Let's jump up to page 54, and we'll talk about some of the specified, built-in, whatever you want to call them, data types that you have available to you in SQL. Most data types that you use are predefined, which means that there's a list of what are considered to be valid data types. Sometimes, though, these valid data types are not enough, so you have to create or construct your own, and that's what they're talking about in here. There's also a user-defined, which are very similar to the other ones. Okay, so let's talk about the different types of data. String data types, which typically work with character strings. We're just, right now for us, we're just concerned with the first one. All right. We've looked at this a little bit already, but just to show you one more time, we've got varchar. I don't know if we've got any in here that are char, but let's suppose for a second, I'm going to get rid of it right away. I'm not going to save this, but let's suppose I came in here and under artists, which was down here someplace. There we go. We also wanted to put, we have place of birth. Let's say we wanted to put in here state of birth. Then instead of a varchar, we might make it a char of size 2. All right, and what that means is, for example, if someone was born in Missouri, that state of birth would be MO. If they were born in Chicago, that would be IL, etc. So the main character types are explained and shown on the chart here. We care about char and we care about varchar. All right. Numeric data types. Middle of page 57. You can have what are called exact numerics or approximate numerics. Exact numerics are whole numbers. Approximate numerics are fields that can have percentage of a field. When you work with numerics, you can set them up in many ways. This example right here, and I want to make sure you understand this. So the example that's shown right here, all right, what that means is max of 5 digits. That's what the 5 means. So in other words, the biggest number would be 1, 2, 3, 4, 5 nines. All right, that's the first number. So First number is total number of digits. The second number is the number of digits after the decimal point. So the 2 means this. So with numeric, 5 digits, you can see there are 5, and the comma 2 is how many of those digits appear after the after the period. Usually you see it written like this too. You don't have to, but usually you see it written like that. All right. Data types, and I think that's date-time data types. You have 3 different date types that you can use: date, time, and timestamp. Notice that all of them refer to what used to be called the GMT, or Greenwich Mean Time. Typically today they're known as UTC, or Coordinated Universal Time. The major types are shown in the chart that's on page 59. Again, I don't plan on going over any of this stuff. I'm just trying to expose you to it, so to speak. There are interval data types mentioned on the top of page 60. Notice the value of an interval data type represents the difference between 2 date-time values. All right. You should never store anything in a database, a field like age, because age is technically, it's always changing. I'm a year older today than I was yesterday. I'm a year younger today than I will be tomorrow, type of an idea. So any field that's like that has to be calculated, you should never store it. But if I stored the current date in my table, and I stored my birth date in the table, I could subtract my birth date from the current date, and I could find out my age at any time. Okay? I can use intervals as a part of that if I so choose. The Boolean data type. Boolean is true-false. Under the covers, so to speak, normally true is 1 and false is 0. But technically, I believe that other than 0 or null, which we'll talk about more in the next chapter, everything in SQL would then be, other than that, would be true. Another Ask the Expert here on page 62. And then the author actually shows you some of this stuff. It says, now that you've taken a look at the various predefined types, let's look at a create table statement. Well, that's what I did with you before. What's different on here as opposed to the example that I went through, there's a date field and there's a Boolean field. So again, it's a true-false field. All right. Creating user-defined types. Again, SQL supports 2 types of user-defined types. So what you're saying is, I want to be able to put in some type of data, but I can't use one of the standard names for it because they don't meet my needs. So you can have structured types, as it says, these are made up of 1 or more attributes that are each based on another type. And we can have distinct types based on predefined data types and whatever parameters we want to add for these. You also, when you set this stuff up, can specify default values for a column. If, let's say that I'm working for the state of Missouri and I'm creating a website for Rankin Technical College, and one of the things they want in there is a form. And on the form they want us to enter the state. Well, if it turns out that 99% of people who come to Rankin are from Missouri, I probably don't want to I would rather use a default value for state. And if somebody is not living in, in Missouri, maybe they're in Illinois or whatever, then they can change theirs manually. And that's what we're talking about here. And they give you an example too on page 65, how you can set up a default value. Next is a step-by-step exercise where the author has you come in there and create a table. This is probably important enough that let's not use their example, but let's create our own. Okay? So in the example that I showed you before when we had this, let's say I want to create this person table. All right? So I'd probably come in here and do something like this. Create table person. First I'd have my ID field, and that ID would be an int, and it would be a primary key, and it would be auto increment. Next, I would have a first name field. I'm going to keep this simple. I'm going to call it FN for first name. That would be a varchar, variable character length, of let's say 30. Then I would have a last name field, which again will make a varchar of type or of size 30. And then we'd have an address varchar, and we'll make that of size 50. A city, which will be another varchar of size 30. A state, let's make that a char of size 2. A zip code, which will make a varchar 10. And a cell phone, which will be a varchar we'll make it a size 14. And that 14, so we could have parenthesis, area code, parenthesis, space, exchange, space, number. And I believe that adds up to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There you go. To signify that I'm done, I put in this. So what do we have? We've got this is a data definition language statement, a DDL statement. We're creating a table. We're naming it person. Our delimiters are open and close parentheses. We need a semicolon at the end to say that we're done. These are our 1, 2, 3, 4, 5, 6, 8 fields. An ID, a first name, a last name, an address, a city, a state, a zip code, and a cell phone. These are the field types right here. And if need be, I also specify a field size. All right. So they have you go through this step by step on page 66 and 67. Then they mention on the bottom of page 67, sooner or later, you're going to create a table and you're going to screw it up. You're going to have something in there you didn't mean to have in there. So you can alter a table where you can add things you forgot to add, change things that are in there, and remove things that are in there. Notice it's alter, again, another DDL or data definition language, where you can literally alter things. You can add, they don't use create, they use add here, and you can drop things. And this cascade is important, and we're going to talk about that. I don't remember if we talk about that now or in the next chapter. Looks like it's in the next chapter. In general, they mention on the bottom of page 68, the alter table statement is a handy one to know because invariably table definitions are going to change, and so too are the types of data stored in those tables. So over time, things happen. Something may need to be added, something may need to be removed, something may need to be modified. That's what they're talking about in here. You can delete a table by using a drop table. There's also a truncate option that you can use. But this pretty much is it for the chapter. All right, so we'll come back in a couple minutes with Chapter 4, which is on enforcing data integrity. And again, we'll come back with that chapter shortly.